2 minutes has passed, so welcome to this Snack and Learn webinar. I am Kasper Nielsen speaking to you today with my great colleague Søren Gabriel. Today we're going to talk about the same as the title says here, namely aiming for net zero, reduction of carbon footprint in climate adaptation projects. But first of all, a bit of a introduction to who we are. I am Kasper Nielsen, as seen on the picture here on the left. I am net zero lead for WSP in Denmark, and my work is primarily focused around greenhouse gas accounting, around climate strategies, and around the very important science-based target work. I have a background as a Master of Science in Climate Change and is currently employed as a strategic sustainability consultant at our Department of ESG Advisory. With me today is Søren Gabriel, pictured here in the center of your screen. Søren is head of R&D here at WSP in Denmark. Søren primarily focuses his work around climate adaptation strategies, around stormwater management, and around the net zero work that we do in general. Søren, he has been here for 25 years now and is employed within the Department of Climate Adaptation and Urban Development. Both Søren and I, we are based here in Copenhagen at WSP in Denmark, where we are 450 employees, more or less in total, so we are not that big yet. But we are split into 3 divisions, starting off with Earth and Environment, where Søren and I, we are employed in, and then we have Transport and Infrastructure, and then we have the remaining division of Property and Buildings. But that was the introduction. Now we're going to head on to the agenda, where I will kick off. I will start off explaining the net zero journey that we are on in WSP in Denmark. Then I would explain briefly why net zero is that important. And then we're going to move on to the emission gaps that we have seen within the climate adaptation sector. Søren's going to talk a bit about the key learnings from the building sector that we can use within climate adaptation. And then Søren's going to talk about the findings presented in a case study from Albertsen, just west of Copenhagen. And that's all going to be wrapped up in the net zero hierarchy. And as I said before, we will have time in the very end for a Q&A. But if we don't manage to answer all of your questions, then just please reach out to me and Søren afterwards. We would most naturally get back to you shortly after. But let's head on with it. I will turn off my camera and we will head directly into the net zero journey that we are on here in Denmark. As you can see, we started our work back in 2018, where we got reduction targets from WSP Global that made us sit down and calculate our carbon baseline for scope 1 and 2 in 2019. But things change, and now we are in 2022, and in this year we have pledged to halve the carbon footprint of our designs and advice by 2030. And this is not only the design and advice that we do in climate adaptation, this is also in the building sector, it is in infrastructure, it is basically in all of the business units that we have here in WSP in Denmark. But by pledging to such a goal, we also need to calculate our carbon baseline, and this is a thing that we will complete by end of this year, allowing us to benchmark in early next year. But as you also can see, we have a target to become net zero in operation by end of 2025. And that leads to the final goal that you could see here, namely that by 2030, we should have halved the carbon footprint of our designs and advice. And that might seem like a really hard thing to do, but what Søren and I, we have actually experienced, it is not that hard, at least not as hard as we thought. It is more about a change in mindset, it is about a change in the way we think, and it is about a change in the way we design projects. But Søren will come back to this later on. But first of all, what does net zero mean and why it is important? That can you basically see here on your screen now. This is a figure describing the global average temperature and a lot of scenarios for that. On the x-axis, you have the years going into the future, and on the y-axis, you have the global average temperature increase relative to a pre-industrial period. And as you can see, once we as a globe reach net zero CO2 emissions, global warming would stabilize. That means no more temperature increase. And if we manage to do that and also onwards manage to be net zero in all of our greenhouse gases, meaning methane and whatever, and all greenhouse gases, then global warming would peak and then start to slowly decline. And that decline, that would be accelerated further if we manage to be net negative in greenhouse gas emissions. But that is quite reliant on carbon capture and storage, so we would see where we end there. But how is our contribution to the net zero agenda in climate adaptation? As you can see here, this is a typical project from a Danish climate adaptation plan, where we previously have focused a lot about the use stage of the given project. That means we have a lot of focus around operational carbon. And this is a thing we have actually been extremely good at in a Danish context. That means as a country, we are really good at focusing and optimizing our energy and carbon emissions, but only in the operational phase of a given project. And that made Søren and I think, what if we sort of incorporated all whole life carbon emissions? How would that change the picture? Yeah, obviously, the answer to that question is to the worst. And as you can see here, if you start to incorporate the entire lifetime, whole life carbon of the given project, that also means that not only the operational carbon, but the embodied carbon as well. If you include the carbon emissions from the practical completion of the project itself, the ongoing emissions from replacement and maintenance, and the as important end of life emissions, then the picture would change quite dramatically. But exactly that journey that we are now on within climate adaptation, the exact same journey has the building sector actually been through over the last couple of years. So therefore, Søren will now take over and start to talk about the key learnings from there.
Thank you. Next slide, please. What I'll be telling about is Danish experiences, or at least based on Danish experiences. But we were very thankful to our UK colleagues who've been doing a lot of work on the same thing, net zero work on the building sector. But we have the University of Aalborg in Denmark. They've been working intensely for the last 5 years on life cycle assessment on the building sector, and they have managed to get it into the regulation, and I'll come back to that. But as Kasper said, we've been on a journey since the 60s. The left part of the figure here shows the energy consumptions in kilowatt per square meter of buildings, starting in the 60s with a net consumption for the operation at 350 kilowatt hours per square meter, and then ending up with our building regulations 2020 with 20 kilowatt hours per square meter per year. And that's quite a reduction, and that's due to systematic work, and that's due to our regulations in the Danish building regulations. Until 2012, the building regulation, they stated how to construct the building, and the insulation and so on was defined there. But since 2012, instead they defined what would the frame be for the energy consumption. So in 2012, it was stated already that in 15 we should reach so and so, 18 so and so, and then in 2020 we should reach these 20 kilowatt hours per square meter per year. So this reduction is due to a systematic work. And if you look into what the carbon emission is at the same period, the decrease is even steeper, because back in the 60s, the energy production was based on coal and oil, and today it's natural gas and electricity and heat pumps. So we have even steeper reduction here, but still that's operation. And what they showed in the University of Aalborg is that if we focus on the entire life cycle, which is shown on the right, the picture turns out to be completely different. Next slide, please. Last year, the University of Aalborg, they made this project going through 60 buildings. They're all DGNB Gold certified. That's the same as LEED or BREEAM in the British context. And part of this certification takes that they have to make a life cycle assessment on the building, and that way it's easy to calculate what is actually the lifetime carbon emission. And on the lower figure on the right, you can see the carbon emission or CO2 equivalent emission from these 60 buildings in a plot. And on the y-axis, you've got the emission, and it's measured in kilograms of CO2 per square meter per year over a 50 years period. And what's interesting for an old guy like me, I'm used to saying that, well, if you've got something consuming energy, 80% of the consumption or the CO2 emission, that's from the operation phase. But actually it has changed, and it's completely opposite today. So as the figure shows here, it's more like 70 to 80% of the emission that's embodied carbon, and only the rest of it is operational carbon emission. And that's due to more efficiency, and of course at the same time due to more embodied carbon, as it costs carbon to save carbon. But the focus has been on energy instead of carbon, and now changing to carbon, we can include the embodied carbon, and then that gives a chance to save carbon in a total. Yes, let's have the next slide, please. This scientific work has been used to put into the building regulations. On the left, you can see our new national strategy for sustainability, sustainable construction, and in this plan, governmental plan, the table on the right is presented, and that's what's going to be put into the building regulations starting from 1st of January. And as you can see in the bottom, new constructions more than 1,000 square meters already from 1st of January. There's a limit at 12 kilograms CO2 per square meter per year if you want to construct, and you're not allowed to construct if you exceed that limit. And year by year it'll be reduced, 2025, 2027, and 2029, down to 7.5 kilogram CO2 per square meter per year. So even from the Danish building regulations, in 2029 we'll have a reduction by 40%, and our goal is 50%. So I'm sure we'll succeed to get there. Those are the big buildings, and smaller buildings, the regulations will start in 2025. We have a volunteer standard as well. This is like the mandatory standard, but there's defined a volunteer standard in the bottom here, and it goes even lower. And you can ask why work with a voluntary standard, but the voluntary standard that actually represents the way you have to follow if you want to follow the Paris Agreement. So you need a steeper decline to follow the Paris Agreement. But due to discussion within the companies, they ended up with a mandatory standard less strict than the volunteer. That is interesting, and we think that we could get inspired from this and try to get it into our part of the company and see if we can use it in the construction works and the utility works. Next slide, please. There's a single utility company in Copenhagen, around Copenhagen. They're covering 9 municipalities, and they tried to make a similar calculation as the one we saw for buildings. They made this split into scope 1, 2, and 3, where scope 1 is the emissions from the facility, scope 2 is emissions from purchased energy, and then scope 3 is from their construction. And it's based on 2020 numbers, and it's not precise and exact, but it's their best estimates. And the focus has been on scope 1. And then you can see there's some heavy emissions there, and N2O, denitrogen oxide, is the most important. That's emission from the wastewater treatment together with the methane. And there's tendency to focus on reduction here, but when you do the total calculation and see the embodied carbon, you can see that exceeds the operational a lot. So there again, there's a reason to focus on the embodied. Next slide, please. To use this within our area and within other areas, because of the method we've developed is going to be used within the roads and rail and within our environmental division as well. But now we're starting to present what we're doing in our field. We have to start to find out what are the goals, what are the goals our clients are working with. So for the utilities companies, the goals are politically agreed service levels. How much water should they contain in the sewer system? There are recipient goals determined by the EU. Of course, we've got political goals of swimming water. We're swimming in the harbor in Copenhagen, as you can see. Then we have economical goals, and then the municipality and the users, they've got some goals about livability, biodiversity, etc. And now we're introducing an extra goal, which is about CO2 emission in construction and operation. And as soon as you start introducing new goals, of course, there's a switch in what are the good solutions. And that's a challenge to get people to accept that and to work with these new goals and prioritize them. Next slide, please. For that purpose, we developed this circle, and again, it's inspired from our British colleagues within the building sector, but we have changed it a bit. So we're starting in the upper right corner and saying we should start to consider, could we build less? Is it actually necessary to build? So start prioritizing carbon footprint over other goals, postpone projects to save CO2. If we can postpone a project 10 or 15 years, the construction will emit less CO2 due to cleaner energy and cleaner materials. Maybe we could renovate and use remaining lifetime. We have to build for the future and only build what's needed and then build flexible, not build too big. And then, of course, we have to think if we can involve citizens and municipalities and so on. But that's a strategy and planning phase. And then we come over to design and construction phase, where we have to build wisely, we have to build light, with lighter materials, and we have to build low carbon. This circle is important because as engineers, we tend to jump directly into building low carbon. As soon as I start talking net zero to our engineering colleagues, they're like, oh, couldn't we just use reused materials? And that's important for sure, but there's a lot of carbon to save in the other compartments of this circle. And I've got some examples to prove that. Next slide, please. We made a project for the utility company and the municipality of Albertsen, just west of Copenhagen. And it was about making some extra detention capacity in an existing stormwater system. So it was like a climate adaptation of this system, because our calculations showed that in 100 years, they would need this capacity. And we were building in an open space, and they wanted to have the detention capacity established. Now they had the chance to do it. Next slide, please. So the challenge was that we had to make like 10,000 cubic meters extra detention capacity in this area, and then we had to find a way to do it. The client, they wanted to do it in concrete pipes like these box culverts because they're easy to maintain. Our construction colleagues, they were like, they're heavy and they're expensive. Couldn't we rather do it in plastic pipes, polypropylene? I was like, we could save a lot of weight if we went into plastic cassettes lined with a membrane, or we could even make an open pond, because that's possible. There's a park in the area. And you can see the carbon emission, CO2 emission in kilograms per cubic meter detention volume for these solutions. There's a factor of 200 between the best and the worst solution. So there's a lot of carbon to save. And this is about building light, and this is about building low carbon. So of course, being an engineer, going directly into the solution and see what can you save by building light and building low carbon, there's a huge potential. I mean, reducing by 99.5%, that's something. Next slide, please. But there are also other ways to do it, and that could be in the other compartments. This picture on the right is from the catchment where the water comes from. So the reason we need this detention volume, extra detention volume, is that we've got such a lot of pavement in this area. And the area is actually already planned for urban transformation. So it's going to be transformed into a residential area, as the one you can see in the right side of the picture. And if you do it in a proper way, you can reduce the paved area, and you can reduce the flow of water, the intensity of the discharge, and maybe even you maybe even shouldn't need any extra detention capacity, because you do something in the catchment instead of making extra detention capacity. Next slide, please. Another way, if you go into other compartments in the figure, could be to go into this build less and discuss whether you should focus on the service level. The service level is in this area is that you're not allowed to have more than standing water on terrain more often than once every 5 years. And you have to adapt the sewer to contain the water until a 5 years event. But you could ask yourself, is it a problem to flood an area like this temporarily over the summer, maybe 5 times every summer? I mean, it's snow covered almost the entire winter, or it used to be at least snow covered all the entire winter. So by working with the people owning this area, you might get an acceptance that the sewer system doesn't have this capacity, and if you don't need to exceed the capacity or make it bigger, you don't need to make extra detention capacity. So these are examples of how you can work in different parts of this circle, and we use the circle in workshops with our clients. So when they come to us with a problem or a project, we'll come back to them and say, could we do some kind of workshop and brainstorming on what is the problem, and could we solve it in another way rather than building detention volumes or making new separate sewer systems or some other huge projects. So it's quite an efficient way to work with the client and be constructive and creative with the client. Next slide, please. To do so takes some kind of systematic approach, and the circle is one thing, but you have to have some knowledge about your sector. And what we're doing, as Kasper said, we're doing like a baseline study. What's the sector and what's our project emission of CO2? So that's one thing we're doing, and the other thing is we have to be able to calculate the CO2 emissions, and that's the LCA, life cycle assessment calculation you do here. And there's a lot of different tools to do LCA calculations, and I mean, we are using like 3 or 4 different tools. It depends the client what they prefer, but they are basically just spreadsheets with a database behind them, and it's quite easy. But we're getting quite a good overview of the CO2 emissions from our sector, from the stormwater sector. Next step is to go into the circle and challenge the goals and the paradigms for how you do things, and then go on to the plans, see if you can do plans with lower carbon emission, and then of course in the end when you end up with a design, see if you can optimize the design and get even lower with the carbon emissions. So that's our approach, and I can just recommend to try to use it because it is it's efficient. It gives a good overview, and you can use it as an internal tool, or you can use it with your clients. Thank you.
Thank you, Søren and Kasper, for a fantastic presentation. So just some housekeeping items again before we get going. The presentation slides are available to download in the handout box as a PDF, and please feel free to ask questions in the question box on the GoToWebinar control panel. Kasper, if you can open your webcam as well, it would be really nice to see you. I will start with the first question that we have. Which factors have the greatest influence on the calculation results for the evaluation of carbon footprint in climate adaptation projects?
It depends where you are in the circle. I would say that the most important factor is what are the goals you're working to reach. So if you could convince your clients to postpone the project or to change the goals of the project, of course, that has a huge impact. But if you're in a design phase, I would say it's the materials that has the most impact. The processes, the machines you're driving with, the transport and so on, has of course an impact, but the materials tends to be the most important part.
Thank you. How do you determine the best baseline and carbon load from projects so that you can document that you reached a 50% target?
I think that is a question to our baseline work, and we are calculating our baseline based on this year, namely 2022, and from this year we are taking 10% of the turnover from every single business unit that we have, including climate adaptation, most naturally. And by doing so, we can estimate what our baseline year is, and once we are finished with that section, we will most naturally increase the amount of percentage of the turnover we would include within our baseline calculation to sort of improve the quality of the work. But the most important thing is not to do it the correct way in the sort of the early stage in the first place. It's not about doing it correct, it's just about get going, honestly, since as soon as you get going, you'll get data and you can act on the data that you have.
Thank you. The next question here is about international standards. Is there an international standards for deriving carbon volumes?
No, I wouldn't say there's a standard. EU is working or just started to work on a standard when it comes to buildings and constructions, but from country to country and the project to project, people tend to work with different standards and tools.
Thank you. Did you experience any other adaptation projects other than stormwater management?
If we experience them?
Like if you have, I assume the question is relating to the circle, and did you implement this circle in other adaptation projects besides stormwater management?
No, we're about to do it on a landscaping project. It's like construction, the landscape around a new development. And I'm just about to start a work together with our road people to do it on roads. Right now we've got an intern working on pavement. I think we've got 25 different pavements she's doing calculations on. So yeah, I'd say we are on our way, but still in the very beginning.
Yeah, and then if I just can add, let's say the original circle from WSP in UK is broadly used within our property and building sector.
Thank you. Are there necessary tools and data to calculate accurate carbon footprint available in the market?
Yeah, I would say so. Define accurate. They are accurate enough. They are indeed accurate enough to act on. And let's say this is for Søren and I. This is basically our message. We have enough data to act, and it's just a matter of get going rather than waiting until you have precise data on basically on every single parameter of the project.
Thank you. Is it realistic that WSP can get the clients to reduce the carbon load with 50% in scope 3? I guess it refers to the first slide that you presented.
Yeah, I think so. I'm sure. I mean, within the building sector, they almost have to anyway. And my experience from our sector is there's a huge interest, but there's a frustration because everybody are talking about carbon and net zero, and nobody has a systematic approach. And by introducing this approach, my experience is that the clients, they're like, wow, we're gonna do this together with you, because I mean, it might not be the best way to do it, but at least it's a systematic way. And people want to change things. So I think there's an interest, and I think we'll get there. And the baseline studies we're doing in my department, they're almost all of them are financed by our clients because they want these calculations, and they can see there's a need for it.
Thank you. I will take the last question. This is regarding the utility example. It says it's a comment and a question. I was surprised by how high the embodied carbon elements was in the utility example that you provided. Can you elaborate on this? For example, is this a new building scenario, and how would you anticipate this would change in a situation when a utility is mainly maintaining an existing asset base?
Yeah, this is, I mean, the footprint you see with the concrete box culverts and the polypropylene pipe, the footprint is due to new materials. We don't have very much data on reused plastic, but it seems to the data we have is partly reused plastic, and we can reduce the footprint by 50%. But it is new materials that's a problem. We have data on sewer renovation, where we've made a comparison of making a different kind of sewers from concrete, plastic, and renovation of sewers with a lining of existing sewers. And we can see by doing such a, I don't know the English term, but it's like a fiberglass lining of existing sewers. And by doing that, we can reduce the carbon footprint compared to new sewers by, I mean, 85% or something. Again, depending on the project, but constructing with new materials produced today is very heavy in carbon. But within 10 years, 15 years from now, that picture will for sure change because we use less energy, the materials emits less carbon.
Thank you for clarifying this. So we're at the end of our webinar session. Thank you so much for joining us today, and thank you, Søren and Kasper, for a fantastic presentation. Please feel free to follow up directly with the presenters via the contact details shown on the screen. So thank you, everyone.
Thank you.